Hello student. Let's start the new topic from unit 2, crude oil characterization. So crude oil characterization, as you can see in the picture, the different color oils are kept. This means these oils are characterized and found into the different reservoir areas. So if we talk about detail in the crude oil characterization, that has a long been an area concerned in the refining. However, the need to identify the chemical nature of crude oil and has gained an importance in oil and gas operation. Traditionally, this has been done by simply stating the crude oil gravity. So we will separate the crude oil that is found into the different reservoir in all around the world based on their uh, specific gravity or oil gravity. So only pressure, temperature, specific gravity and relative amount of each component are used to characterize the crude oil PBT properties. So crude oil, each component is can be used to characterize the crude oil all around the world. So the crude oil can exhibit regional trends in the chemical composition, placing them into one of the following groups. One is paraffinic, naphthenic and aromatic. So based on these three groups, the crude oils are categorized: paraffinic, naphthenic and aromatic. So aromatic hydrocarbons are greater than 70% of the total world's crude oil, and normal paraffins are greater than 50% in total world's crude oil, and naphthenic hydrocarbons are greater than 70%. So you can see the map of the world where the aromatic hydrocarbons are found. These are the square areas, and the black circle is basically paraffinic crude. These are the areas where we can find the normal paraffins, that is greater than 50% of the world's crude. And naphthenic hydrocarbons, this triangle can show you the naphthenic hydrocarbons all around the world. Next is classification of hydrocarbon, that is based on structure. So based on structure, according to the structure of molecules. So paraffin hydrocarbons are characterized by open or straight chain joined by single bonds. Examples are methane, ethane, propane and decane. So based on the structure of the molecules, the crude oil are categorized into methane, ethane, propane and decane. So again, next is resin and asphalt. Resin and asphalts are found within the crude oil, are the color and black component found in the oil and are made of relatively high molecular weight, polar, polycyclic aromatic ring compounds. So these are the resins and asphalts that are present within the crude oil. So based on that, the crude oil is characterized. This is the table that can give you the description of detailed crude oil composition. So this is the detailed crude oil composition. In the crude oil, with the paraffins are, these are the paraffins, all normal paraffins from C10 to H22. Then we have isobutane, 2-methyl butane. All these components are paraffinic components that are found in the crude oil. And crude oil is the composition of the crude oil is from these three. Naphthenes, these are the type of naphthenes: cyclopentane, cyclohexane, like this. And we have aromatics: benzene, toluene, xylene, ethyl benzene. So these are the aromatics composition into the crude oil. Next, talking about the API gravity. Based on the API gravity, the crude oil is characterized all around the world. So you can see the API gravity is preferred gravity scale, which is related to the specific gravity. So this is gamma naught is the specific gravity minus 131.5. So that's how the API gravity can be calculated for a crude oil. So first you have to find out the specific gravity. How the specific gravity is calculated? The density of the crude divided by the, with respect to water, divided by the density of water. So that is the formula for specific gravity, and then API gravity can be calculated using this formula. So characterization factor, into the characterization factor there was a one scientist called Whitson has suggested some use of the Watson characterization factor. So this Watson characterization factor he discovered in 1933. Watson and Nelson, they introduced the ratio between the mean average boiling point and specific gravity that could be used to indicate the chemical nature of the hydrocarbon. So Kw is your Watson factor, that is mean average boiling point TB, the ratio power 1 by 3 divided by the specific gravity of the crude. So you calculated the Watson factor, and Watson factor is used in, it is a characterization factor that are useful because they remain reasonably constant for chemically similar hydrocarbon. This ratio remains constant for chemically similar hydrocarbons. If the hydrocarbons are similar, this constant is going to remain, this factor is going to remain constant. So characterization factor of 12.5 or greater, this will indicate the hydrocarbon compound is predominantly paraffinic in nature. That means more paraffin compounds are there into the composition of hydrocarbon. If the characterization factor is 12.5 or greater than 12.5. Now next we have lower than 12.5 values of this factor. It will indicate the hydrocarbon with more naphthenic or aromatic compound, and if they are highly aromatic hydrocarbon, this will exhibit the value of 10 or less than 10 into the highly aromatic compound. The Watson factor will be less than 10, and therefore the Watson characterization factor provides a mean of determining the paraffinicity of a crude. That means how much paraffin is present into the crude oil. This is characterized by using the Watson factor. So using work from Riaz and Doubter, they were also the scientists, they worked into the crude oil characterization, and Whitson. So both all three this developed, they developed a relationship between the term molecular weight and specific gravity, that is 4.5579 into molecular weight power point 1.15178, specific gravity minus the power minus 0.8.84573. So this is the Riaj Whitson factor. So this is also a Whitson factor that can be calculated using the molecular weight and specific gravity. So this table you can see Watson characterization factor for selected compounds. We have paraffin series, naphthene series, and aromatic. And in paraffin compound we have hexane, methyl pentane, heptane, and this is their boiling point. This is molecular weight, this is specific gravity, and this is the Watson characterization factor. So it is 12.8, 12.8, 12.7. So greater than 12.5 in paraffins. And for naphthenes you can see this is around 11, 11.3. So it is greater than 10, and in aromatics it is around 10, 9.7 or 10.1. It is less than 10 or around 10 into the aromatics. Next table shows you the sample of worldwide crude oil properties. So this is a reservoir that is obtained from different reservoir area, like you can see Boscon, Cane River, Quantum, Vampire. So these are the different areas from where we got the reservoir. These are the areas: Texas, Oklahoma, the crude received in USA, country USA, Angola, Indonesia, all these. This is their API gravity and this is their Watson factor. So Watson factor is greater than 12.5 is a paraffinic, less than 12.5 is a naphthenic, and less than 10 it is a aromatic. So more aromatic compound will be there if the Watson factor becomes less than 10. So you see the crude oil typically have characterization factor ranging from 11 to 12.5. So this derived from assay data available in the public domain. It sample crude from the around the world and can be used to provide insight into PVT behavior on a regional basis. Next we have sample of worldwide crude properties, reservoir, areas, countries, API and the Watson factor. So this is in between 11 to 12. So mostly paraffinic crudes, or you can characterize what kind of crude it is obtained from different countries or different areas. So this can be characterized based on the Watson factor. This is another characterization of the crude oil, depicts a relationship between crude oil gravity and characterization parameter. While not definitive, it can be observed that lower gravity crude tend to be more naphthenic, while lighter gravity crude tend to be more paraffinic. If the API gravity is low, then the lower gravity crude, this is tend to be more naphthenic. So this is naphthenic crude, and if higher gravity, that is paraffinic crude, means more amount of paraffin composition present into the crude oil. You can see the API gravity chart at API gravity and Watson characteristic factor chart. So on x axis you see the API gravity and y axis you see Watson characterization factor. So different types of different crude oil have different Watson factor and different API gravity. So as you see the API gravity increasing, the Watson characterization factor is increasing. So that means for higher Watson characterization factor, we have higher API gravity, right? It means if higher gravity crude you have, that means your crude is more paraffinic, and if lower API gravity you have, your crude is naphthenic, more naphthenic. Naphthenes are more. Here we show the characterization of the crude oil based on other parameters. Like for example, for trading purpose, the crude oil can be characterized based on the density and API gravity. For the transportation, the uh, crude oil can be characterized based on the RVP, that is rapid vapor uh, vaporization point, and power point, kinematic viscosity, wax content. So based on the transportation purpose, the crude oil can be characterized on the basis of rapid vapor point, power point, kinematic viscosity, wax content, etc. And contamination based on the contamination, salt content, and then BS, base sediment and water present into the crude oil. For the processability, sulfur content, nitrogen content, total acid number, asphalt, and then uh, the crude residue. Then you have the cracking point. Based on the cracking point, we have ASTM distillation, LPG potential, we have the light hydrocarbon and gas chromatograph. Based on the classification, we have characterization factor. So based on the different purpose, we have different property of characterization of the crude oil. So based on all these properties, you can characterize crude oil, for example, for trading, for transportation, for contamination, for uh, processability, for different purpose, there will be different characterization factors will be used. So base, sediment and water is determined by Carl Fisher titration using a MET ROM, that is automatic titration method for distillation. And then oil with significant water content, if it has greater than 5%, do not represent the property of the dry oil. And flash point and fire point of lubricating oil, that can be determined by ASTM methods. So many fresh crude have the flash point below 10 degree centigrade and viscosity is above 9.5 centistroke at 25 degree centigrade. So this is a chart that is defining the other characteristic parameters of the crude oil. You can see we have density, API gravity, power point, kinematic viscosity, water content, then we have sulfur content, total acid number, we have the wax content, asphalt, then distillation cracking point, metal content, nickel, vanadium content. So this is their Basara light, means this is the Basara light is a area where we find the crude oil in India. Then Bombay High is in India. Arab, this is for Arabic crude property, and for Kuwait, these property are for Kuwait, and this is North Gujarat. North Gujarat is in the state of India. So these are the different properties of crude oil, technical properties that is received from different regions. Now into this slide you can see the picture of the different crude oil that is characterized based on their API gravity and sulfur content. So the yellow color picture you see here, this picture is very light uh, crude oil, and this is light crude oil, this is heavy crude oil, and this is heavy sour crude oil. So this is a quality level API gravity and sulfur content. So the class crude oil class, we have ultra light, that is API gravity is greater than 50. We have light sweet, that is 35 to 50, and then light medium sour crude we have 35 to 50, that has sulfur content 0.5 to 1. And we have ultra light, that is the sulfur content is less than 0.1%. Then we have medium and sweet, that is 25 to 35, and the sulfur content is less than 0.5. Then we have medium, then medium and sour, heavy and sweet, then heavy and medium sour, then heavy and sweet. So these are the based on the sulfur content and degree of API, the crude oil is characterized. So crude oil characterization is based on the their flame production yield. So, and x-axis you see the sulfur content. So based on this crude oil is characterized. For example, light sweet Brent, low sulfur, low carbon residue, low nickel and vanadium, heavy sweet, dragging, low sulfur. So all these are characterized based on their API gravity and the content of the sulfur. So mostly based on this crude oil is called by different names. Like for example, you see the ultra light, light sweet, light medium, medium sour, medium heavy crude, sour crude, like this. So based on the sulfur content and their API gravity. So the picture right side you can see this is a capture energy requirement increase on y-axis, and this is the type of hydrocarbons, carbon content and contamination increasing. So different crude oil qualities with respect to their carbon content. So first, low carbon content we have natural gas, and then the carbon number increasing, it becomes the natural gas liquid, then it becomes condensate, then it becomes light sweet crude, and then we have heavy sour crude, then we have bitumen, and then we have coal into this. So now we will come to know sweet and sour crude based on the sulfur content. So depending on the amount of sulfur, the crude oil can be sweet or sour. When the total sulfur level in the oil is less than 0.5%, the oil is called sweet, and if it is more than that, then oil is called sour. So sweet crude oil is more preferred by the refineries as it contains valuable chemicals which is needed to produce the light distillation and high quality feedstock. So that means the sweet crude is very costly because of the less sulfur content, that is less than 0.5%, and it contains very lighter hydrocarbons into it, like more ethane, more ethylene, and it contains more methane gas, like this. So historically, early prospect tested the crude oil to determine its quality. The crude oil petroleum had a sweet taste and pleasant smell if you content if the content of sulfur was low. For this reason, sweet crude is low sulfur crude oil. So if you talk about the sweet crude, that is low sulfur crude oil, the crude oil that contains very low sulfur into it. So sweet crude is easier to refine, safer to extract and transport than the sour crude because sulfur is corrosive. Light crude also causes less damage to the refinery and thus result in lower maintenance cost over the time. And major location where sweet crude is found include the Appalachian Basin in eastern North America, western Texas, Bakken Formation of North Dakota, and South Chuan, the North Sea of Europe, North Africa, Australia, and Far East, including the Indonesia. So, an opposed to sweet crude, sour crude is sold at a discount to higher sweeter grades because the sulfur compound in the crude oil are generally harmful impurities and they are toxic, have an unpleasant odor, contribute to the deposition of resin in combination with water causes intention corrosive. Potassium oil, even though it does not restrain the production of inconvenient crude, and data show that from 1995 to 2011 medium sour and crude has been major hydrocarbon produced in the world, taking about 50 to 60% of the whole crude production. So that means the sweet crude and sour crude is sold comparatively. Sour crude are sold on discount basis because this content very high sulfur content into it, that is harmful for the refineries. So major region with vast sour crude reserve, we have North America, Alberta, Canada, United States, portion of the Gulf of Mexico, South America, Venezuela, Colombia, Ecuador, Middle East, Saudi Arabia, Iraq, Kuwait, Iran, Syria, and Egypt. So based on the other property of the characterization, you can see this chart we have explained based on the API gravity and the heavy, light, and sweet crude. So with different country regions where sweet crude is found, where sour crude is found, where light crude is found, and where heavy crude is found. So grades of the oil you can see into this chart. Now the barrels from an area in which the crude oil molecular character have been determined. The oil has classified and are used as a pricing reference through the world. So for pricing reference, these are the types of crude oil that are characterized. So these are three primary benchmark. So there are three primary benchmark to characterize the crude oil based on their pricing. So North America's West Texas Intermediate crude oil, that is WTI, that is for one type. Another we have North Sea Brent crude, and we have UAE Dubai crude Dubai. So other well-known blends are OPEC, that is oil producing and exporting countries, basket, and then we have Tapis crude which is traded in Singapore. We have Boni light that is used in Nigeria. We have Mexico, Ilithumis and Maya. These are the benchmark of the crude oil that are sold around the world with different names, and this is characterized based on the sulfur content and specific gravity on API gravity. The Energy Intelligence Group has published a handbook which identify 161 different blends in total. Their pricing is as barometer for entire petroleum industry, although in total there are 46 keys of oil exporting countries. So benchmark are used because there are many different variety and grades of the crude oil. Using benchmark makes reference type of easy oil easier to seller and buyer. So WTI and Brent future pricing are used for export to Atlantic basin. So this slide is showing you the future crude oil into the crude oil quality outlook in terms of sulfur content in OPEC 2011, and this is crude oil quality outlook terms of API gravity OPEC 2011. So in 2010, 2015, 20, 25, 30, 35. So this is the sulfur content. So this is crude oil that comes from non-OPEC countries. Non-OPEC countries which are not the member of OPEC. This is complete world crude oil have sulfur content in between 1.2 and this is 1.4 with respect to different years OPEC crude oil. So OPEC crude oil have high sulfur content and non-OPEC country have low sulfur content. So this was the all very small information about the crude oil characterization, and next topic we will continue in the next lecture. Thank you.